Welcome to Foundations of Math 30. This is outcome 30.05, probability of more than one event, lesson 1 on addition of probabilities. So what we're going to look at in this lesson is questions that involve the word or and how we calculate those probabilities. So just a quick reminder of things that we looked at in past outcomes, union and intersection. So remember that the union is represented by A union B, and it's all of the outcomes that are in either A or in B or in both A and B. Okay, so this diagram over here represents the union of A and B. The intersection is represented by A intersection B, and it's all of the outcomes that are in both A and in B. That's represented there. Another word is mutually exclusive. So two events are mutually exclusive if they have no outcomes in common. So for example, if I had a deck of cards, the black cards and the red cards would be mutually exclusive. So when you were to graph their Venn diagram, it would look like that because there are no outcomes in common. And if they have outcomes in common, they are not mutually exclusive. So here is the OR probability formula. So this is kind of the important thing here. Basically, the probability of an event A or an event B happening is the probability of A union B, the word union is or, is equal to the probability of A plus the probability of B minus the probability of A and B, so the overlap. So you take a look at event 1, add an event 2, and then subtract any that overlap if the two events are not mutually exclusive. So let's take a peek at this one. It says the positive numbers from 1 to 15 are written on a slip of paper and placed into a hat. One of the slips of paper is drawn at random. What is the probability of drawing an odd number or a number larger than 8? So I'm a visual person, so I am going to actually just list out all of my possible outcomes here. So my set would be the numbers 1 to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You don't need to list them out, but I'm just a visual person, so I need that. So now I'm going to just use the formula, so practice with the formula. So I want the probability of getting an odd number or a number larger than 8. So I'm just going to use those to represent those two sets. So the formula would say that is the probability of getting an odd number plus the probability of getting a number larger than 8 minus the probability of an odd number and a number larger than 8. Okay? So what we want to do is take a look at just this individual probability and think of it as just a simple little probability question. So I want to ask myself, what's the probability out of all of these numbers of getting an odd number? Okay, so I know that there are 15 possible events, and how many of those are odd? Well, the numbers that are odd are 1, 3, 5, 7, 9, 11, 13, and 15. So that means that I have 8 numbers that are odd. Plus, now look at just this as a simple probability question. What's the probability of getting a number larger than 8? Well, all of these numbers are numbers larger than 8. So there are 1, 2, 3, 4, 5, 6, 7 of them. So 7 numbers are larger than 8. Okay, now this part would be maybe the new part. So this is saying, what is the probability that it's odd and it's larger than 8? So I need to look at my numbers larger than 8, which is this portion of the set, and I want to pick out how many of them are odd. Well, 9, 11, 13, and 15. So 4 of them are odd. We need to subtract those because what happens is I counted them twice. I counted them first when I counted the odd numbers, and then I counted them again when I counted the numbers larger than 8. So we need to subtract that. So when I figure that out, 8 plus 7 is 15. Take away 4 is 11 15ths. Okay, the probability that I have a multiple of 5 or an even number. So that's going to be equal to the probability of getting a 5 plus the probability of getting an even number, subtract the probability of getting a 5 and an even number. So looking at my set out of 15, how many are multiples of 5? Well, the multiples of 5 are 5, 10, and 15. So 3 of them are multiples of 5 plus the probability of getting an even number. Well, the even numbers are 2, 4, 6, 8, 10, 12, and 14. So that is 1, 2, 3, 4, 5, 6, 7 of them. Now, this last one, the probability that it's a multiple of 5 and it's even. Okay, so our multiples of 5 are 5, 10, and 15. How many of those are also even? One of them. Okay, so I would have counted that one twice, so I need to subtract it out. So 3 plus 7 is 10, take away 1 is 9, so I have 9/15. Remember, we have to always reduce our fractions, so this will become 3/5. Okay, let's look at a cards question. So this example 2 says the probability, a single card is drawn from random at random from a standard deck of 52 cards. Find the probability of drawing a heart or an ace. Okay, so that will be equal to the probability of drawing a heart plus the probability of drawing an ace minus the probability of drawing a heart and an ace. Okay, so out of my standard deck of 52, how many are hearts? Well, 13 of them. That's one suit, right? Plus, out of 52, how many are aces? 4 of them. Take away, out of 52, how many of them are both hearts and aces? Well, there's one ace of hearts. So 13 plus 4 is 17, minus 1 is 16 out of 52. And that reduces to 4/13. Okay, let's look at 2B. Says, what's the probability of getting a face card or an 8? So that will be the probability of a face plus the probability of an 8 minus the probability of a face and an 8. Sorry, I'm squishing right up against the edge of my screen here. So that's going to be equal to, so how many face cards are there in my deck of 52 cards? Sorry, a lull there. So my face cards, out of 52, there are 12 face cards. Plus, how many are 8s are there? Well, there's 4. Then how many face cards are also 8s? Well, there are 0, right? There's nothing there. So it's just going to be 12 plus 4 is 16 out of 52, which comes out to 4/13. Now, because there was 0 overlap, these two events are what we call mutually exclusive. Okay, so mutually exclusive means that there's no overlap between the two of them. All right, let's look at example number 3. So it says a red die and a white die are tossed. Find the probability that either die shows a 3 or the sum is 8. Okay, so it doesn't matter which is which. We'll call this one the red one, this one the white one. And I've got a sum of dice chart here, which we talked about earlier, but when I roll 2 dice, the interior part of this chart represents the sum. So I want the probability that either shows a 3 or I get a sum of 8. So that's the probability that either shows a 3 plus the probability that I get a sum of 8 minus the probability that either shows a 3 and a sum of 8. Okay, so if we think about our kind of our chart here, the probability that either shows a 3, well, that would be these 6, 7, 8, 9, 10, 11. So there's 11 all together outcomes out of the 36 where either of them is a 3. Getting a sum of 8, there are, sorry, I didn't mean to cross that out. There are 1, 2, 3, 4, 5. So I've got 5 36ths that are a sum of 8. Now, the last part is saying that either is a 3 and it has a sum of 8. Well, you can see that I have double counted those guys right there, right? Those are the ones that give me a sum of 8 and that are also a 3. So there is 2 of those that I need to subtract. So that ends up with 14 out of 36, which reduces to 7 out of 18. Okay. Now the probability that the red die shows a number greater than 4 or the white die shows a number less than 2. So let's just get our formula down. The probability on the red die, I get a sum greater than 4, or on the white die, I get less than or equal to 2. So it's the probability that my red die is greater than 4, plus the probability that my white die is 2 or less, minus the probability of both of those things happening. Okay, so I'm just going to erase my chart here so that I can kind of start fresh for this question. So the probability that the red one shows something larger than 4, so that would be represented by these two columns in the chart, right? Red die greater than 4 means I get a 5 or a 6. So out of the 36 outcomes, oops, there are 12 of them. Now the white die being less, 2 or less, well, that's going to be 2 rows of them there, so that's going to be another 12. Then I need to subtract any that are larger than 4 on the red and less than 2 on the white. So again, we can see my overlap there. So those 4 are the ones that I counted twice. So 24 take away 4 is 20 out of 36, reduces to 5/9. Okay, so it's not that bad if you use the formula, and you just have to kind of think about it as doing individual simple probability questions and then putting it together in the formula. Okay, so there are some practice questions for you to do there. I want you to go ahead and do those before you move on to the next lesson.